Hi everybody. Today we are going to look at section 3.3 from our Hawks College Algebra textbook on the forms of linear equations. So the first thing we're going to look at is just review what the slope of the line is. And we talked about this already when we looked at our equations in slope-intercept form. But remember, your slope of your line is how steep or how flat a line is. And when we talk about slope, we think of words like rise over run or the change in y over the change in x. And remember, the slope formula is, sorry, it slipped down a little bit, but y2 minus y1 divided by x2 minus x1. Okay, we're also going to talk about the slopes of horizontal and vertical lines. And if you recall, a horizontal line is in the form of the equation y equals a number. And a vertical line is x equals a number. The slope for a horizontal line or a y equals line is 0. And if you recall, here is a horizontal line. I think of like the horizon. And slope is rise over run. And if you look at this line right here, if you notice, I have run from left to right, but I have no rise. So if I were to calculate the distance between these 2 points, and I'm going to say they're 2 places away, my run would be 2, but my rise, it's not going up or down at all, would be 0. And 0 divided by anything is always equal to 0. So any y equals line has a slope of 0. Vertical lines, your slope is going to be undefined. Here's a vertical line. And if I were to plot 2 points on that line, one here and one here. Again, if you look at the rise over run, I have rise, and again, we'll say it goes up 2, but I don't have any movement from left to right, so that would be 0. I can't take 2 and divide it by 0, so the slope of a vertical line or an x equals line is always undefined. Okay, so we are going to calculate the slope of these 3 lines, examples A, B, and C. For each example, I have 2 ordered pairs. And remember, each ordered pair consists of an x and a y value. And it doesn't really matter what you call x1 and y1, as long as you keep your 1's together and your 2's together. So if I calculate the slope of A, remember your slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we are going to do, so we would do -5 minus -3. And it's important to keep the sign of both your numbers and keep that minus sign in there as well. That's sometimes the biggest error people make is sign errors. And then we're going to do 2 minus -4. Again, we'll do addition of the opposite. So on the top, I end up with -2. On the bottom, I would end up with 6. Or if I simplified that, it becomes -1/3. All right, let's look at B. This one's everybody's favorite, I know, because it has fractions. I know you guys are missing out on all your fractions every day, so we'll make sure we add some in for you. Okay, so let's see here. We're going to do y2 is -4/3 minus 1 over 1 minus 3/2. So again, to make life a little bit easier, I need to have common denominators. My 1's, instead of putting a 1 there, I'm going to convert it into a fraction. So I need a denominator of 3. So I'm going to use 3/3. And my other one, I need a denominator of 2. So I'm going to make that 2 halves. All right, negative minus, so keep plus change. It's going to give me negative 7/3 over, and then 2 over 2 minus 3 over 2. 2 minus 3 will give me a negative 1/2. Now, I still do have a compound fraction, which, again, know everybody loves. Same, exciting things when you have two fractions together. Remember, it's a division problem, so I'm going to move up here, have a little more space. I have negative 7/3 divided by negative 1/2, or we do keep, change division to multiplication, and take the flip the second fraction, so negative 2 over 1. So now when I multiply, I end up with 14 over 3, and that is my slope for B. Now the last one we need to look at is C. So again, I'm going to label them. We've got x1, y1, x2, y2. So when I do the math, I'm going to do 7 minus 7 over 1 minus negative 2. 7 minus 7 will give me 0, and then 1 minus negative 2 will give me 3, because you do change subtraction to addition and take the opposite of the second number. Now, I get 0 over 3. 0 divided by anything is always 0. So if my slope is 0, what kind of equation would I have? It's going to be one of our special cases. It's either going to be horizontal or vertical. Take a second, think about it. If your slope is 0, what kind of equation is it? Hopefully you said horizontal, because that is correct. It would be a y equals a certain number for our equation. We'll just make it C for now, just to represent a number. And that is it for calculating our slopes with 2 points. All right, so now they're giving us equations, at least the first two, that are in standard form, and they're asking us to calculate the slope. Remember, you cannot get the slope from an equation that is in standard form, but we can put it into this form we tend to use the most, I feel like. It is our slope-intercept, which, if you recall, is y equals mx plus b. So I'm going to start off and take my 4x minus 3y equals 12. I want to solve for y. So I'm going to rewrite it here. 4x minus 3y equals 12. I'll subtract 4x from both sides. So now I have negative 3y is equal to negative 4x plus 12. And then we'll divide everything by negative 3. And that will give me y equals 2 negatives on that fraction, make it a positive 4/3 x. And then 12 divided by negative 3 would be minus 4. So that means that our slope, remember, m is your slope. So our slope for this equation is 4/3. So m equals 4/3. All right, let's take a look at B. And we have 2x plus 7y equals 9. I'm going to start by subtracting 2x from both sides. And that gives me 7y equals negative 2x plus 9. And then we need to get y by itself, so we're going to divide by 7 on everything. So y is going to be equal to negative 2/7 x plus 9/7. We don't need to simplify it. We really only need the slope from this, but that would be our y-intercept. So our slope here is negative 2/7. And our last one is x equals negative 3/4. This one's nice and easy. There's no y. We can't solve it for y. But if you have an x equals equation, what did we talk about earlier? What kind of line is it? Remember, your graph is a vertical line, and our vertical lines have what kind of slope? Remember, they have rise but no run. So our slope is undefined. This slide, again, is just a reminder of your slope-intercept form. We've talked about it so much that I feel like you guys are perfect with it. But remember, slope is y equals mx plus b. M is your slope. Your b is your y-intercept. And the ordered pair for your y-intercept is always 0, with b being the y value. All right, so here, what they want us to do is find the equation of the line that passes through the point 0, 3 and has a slope of -3/5. Then they want us to graph the line. So we can start out here with our slope-intercept form. If I do y equals mx plus b. All right, I have the point 0, 3. If you look at that point, because there's a 0 in the x part and a 3 in the y part, that makes this my b, or my y-intercept. So for b, I'm going to plug in 3. I know my slope is -3/5, so I'm going to plug that in for the slope, put my x there and my y, and there's the equation of our line. That one was nice and super easy. Now, they want us to graph it. We did this in the last section, remember? You can graph an equation by starting off. We got the y-intercept, so that's my first order pair, 0, 3. So I'm going to plot that right here. My slope is -3/5, so I am going to go down 1, 2, 3, and then over 5. And I always run to the right, 1, 2, 3, 4, 5. So right there, my next ordered pair. And again, if I wanted to do another one, I could. Let's draw our line. Again, pardon my non-straightness. I don't know. I feel like it's the screen that does it. But anyways, that should be, it looks like a beautiful straight line, right, guys? But anyways, you can draw a better line on your paper, I know. All right, now when we write the equation of a line and we're given information, they don't always give you the y-intercept and the slope. So sometimes they're going to give you a point that's on the line, but not the y-intercept. And sometimes they'll give you the slope, sometimes they'll give you another point. So what we need to do is use the information they give us, whether it be a point and the slope or 2 points, and find the equation of the line using our point slope form, which is y minus y1 equals m, or the slope, times x minus x1. Now here, m, x1, and y1 are the constants. There we're going to put the numbers in. X and y are going to be your variables that are in your equation. And when we get done, we'll ultimately turn this into slope-intercept form. So we'll end up having a y equals equation, and we need to have x and y as our variables in the equation. That's sometimes the hardest part with this. So here, they gave us an equation, or excuse me, they gave us a point, -2, 5, and the slope of 3, and they want us to write our equation in slope-intercept form. So because this is -2, 5, and it's not the y-intercept, I can't just start off with y equals mx plus b. I'm going to start off using my point slope formula. Now, some of you may have solved this before in the past, where you do plug in your values and solve for b using the slope-intercept form. You may do it that way if you want. I'm going to practice with the point slope formula, but either way is okay. So my point slope formula, remember, is y minus y1 is equal to m times x minus x1. I'm going to plug in my values for my point in the y1 and the x1. So I'm going to end up with y minus 5 is equal to, my slope is 3, so 3 times x minus a -2. And then on the inside, that minus a -2 becomes plus 2. And now what I'm going to do is I'll distribute the 3. So I'm going to have y minus 5 equals 3x plus 6. Add 5 to both sides. So y equals 3x plus 11. And that would be my equation in slope-intercept form. I made it y equals, so y equals 3x plus 11. Not too bad. All right, so the last example for this section is we are going to find the equation in slope-intercept form of the line that passes through the 2 points. And our 2 points are -3, -2, and 1, 6. So here, I mentioned this before, sometimes they give you a point in the slope, or sometimes they give you 2 points. Since we only have, or we have 2 points here, we need 1 point in the slope to find the equation of the line. So what we're going to have to do first is, using our slope formula, y2 minus y1 over x2 minus x1, we have to find the slope of our line. So again, you can label them if you want: x1, y1, x2, y2. I know that's a little small. My slope here, though, I'm going to do 6 minus -2 over 1 minus -3. So that'll be plus the positive. That gives me 8 over 4. And then when I simplify that, 8 divided by 4 is 2. So that is my slope. Now, when you put it into your equation, you can choose either point that you want. Doesn't matter if it's the one you labeled x1 and y1, you can convert the other one to that. Because it has positive values, I'm going to choose 1, 6, and then use my slope here. Again, you could have done it with the other point. You would get the same result in the end. Doesn't matter. So now I'm going to use my point slope formula. I'm going to do y minus 6 is equal to 2 times x minus 1. I'll go ahead and distribute my 2. So I have y minus 6 equals 2x minus 2. And then I want to put it in slope-intercept form. So I'm going to add my 6 to the other side. And I get y equals 2x plus 4. And that is the equation of my line. That is it for 3.3. Look for some classwork that I'll post along with this video so you guys can practice this, and then do your Hawks homework.